All right, no. Today we're learning deductive reasoning, okay? So inductive reasoning is you see from observation and you make a statement about it, and a counterexample can prove it not true. Deductive reasoning uses symbolic logic to represent logical statements and form conclusion by applying the laws of logic to a true statement. These are two laws of logic, and you can have these on your postulate and theorem sheets. One is the law of detachment. If P is true for Q, is a true conditional statement, P is true and Q is true. If the hypothesis and the conclusion of a conditional statement are true, then both the hypothesis and conclusion are true. Law of syllogism. If P to Q and Q to R are true conditional statements, then P to R is true. So if your hypothesis to your conclusion is true, and that conclusion turns into a hypothesis, and that's true to a different conclusion, then your original hypothesis is true to your new conclusion. And I know it sounds confusing, but I'll give you like a million examples, so it'll be okay. Maybe not a million, but a lot. All right. Deductive reasoning uses facts, definitions, and accepted properties in a logical order to write a logical argument. This differs from inductive reasoning, in which previous examples and patterns are used to form a conjecture. Okay, so we're going to talk about example 1, and first we're going to talk about the symbolic things for logic. Okay, so these are slightly important. These are luckily typed because my handwriting is so pretty. All right, we're going to use P and Q, and we're going to write the symbolic statements in words and deciding if it's true or false. So P is always the sky is cloudy. Q is always it is raining. Okay?
I like how it actually is cloudy and it's raining outside.
I know, it's really awesome, isn't it? Okay, I did it all on purpose. I changed your whole thing just because it was, no, not really. All right, the little funky symbol that's in front of the P, this symbol, when it goes like, come on, draw on the board. I love computers, I love computers. Okay, this right here, that symbol, hold on, line the board.
Are we writing this?
Yes, you're writing the stuff that I have typed up on the board. But you're writing nothing right now because I'm aligning the board. But when I am done, yes. There we go. Okay, so that little funky symbol in front of P negates it. Okay? It changes it from positive to negative. The same if you have a little funky symbol in front of Q. It means negative. Okay? So if we look at A, it wants the negative version of P, and B wants the negative version of Q. So they are right here. So the negative version of P is the sky is not cloudy. The negative version of Q is it is not raining. For C, we're going to make an if-then statement. We're going to take our hypothesis and our conclusion. So our hypothesis is if the sky is cloudy, then it is raining. And we know this is a false statement because there's often times when it's cloudy but there's no rain coming. Now we're going to switch Q and P. And what do we call it? What do we call it when we switch Q and P?
Inverse.
We call it the converse. This is the converse. If it is raining, then the sky is cloudy. Now, I've switched them, but I've made them negative. So what is that called? Contrapositive, good. Which I don't think I'm spelling correctly, but close enough. If it is not raining, then the sky is not cloudy. Yes?
So basically, if it says, like, C, you need to write down if the sky is cloudy, then it is raining.
Yes. Because what it's doing is making you write the symbolic things for it. And then F is your inverse. If the sky is not cloudy, then it is not raining. Has anybody, and it's false because has anybody been somewhere where it's beautifully sunny out and there's rain coming down?
Yes.
Yes. So that's why that's false. Eric, do you have a question?
Not much on page, please go a little slower.
Sorry, it's already typed up, so I forget how slow you guys have to write it. So we've got our if-then statement, we've got our converse, we've got our contrapositive, and we've got our inverse. And every single one of our statements is false. If the sky is cloudy, then it's raining. That's not necessarily true. If it is raining, then the sky is cloudy. That's not necessarily true. If it is not raining, then the sky is not cloudy. There's plenty of times when it is not raining, but the sky is cloudy. If the sky is not cloudy, then it is not raining. That's what we talked about being where it's sunny outside, but you still have rain. Do we need another minute? Okay. If you are already done, you can go ahead and try A and B, where your hypothesis, your P, is today is Monday, and your conclusion is Q, there is school today, and you're going to write the contrapositive of an if-then statement, and then you're going to write an inverse. So you guys should be trying example 2. Do we have any questions about example 1? Yes, Rita.
We write if-then statements and then decide if they're
True or false? Yep. I'm going to move on, but if you guys need me to repeat anything up here, I will after we're done. Oh, man. Why do you do that all the time? It's like you hate me. This is not what I want. I want A. So we're looking at example 2 then. Yeah, I can put it at the bottom. And then I can move this over here. All right. So P to Q is if today is Monday, then there's school. So the contrapositive would be if there is no school, then it is Monday. Do you see how we switched and made it negative?
Then it is Monday.
Then it is not Monday. Okay, and we've got the inverse. If today is not Monday, then there is no school. Okay, now we're going to talk about the law of detachment. And again, the law of detachment is if the conditional statement is true, then the hypothesis and conclusion both have to be true. And if we turn it over on the back, we're going to look at these. I'm going to scoot this up just a little bit.
What, all of it?
Yep. I'm going to move this up, but not too far. Jamal knows that if he misses the practice the day before a game, then he will not be the starting player in the game. Jamal misses practice on Tuesday, so he concludes that he will not be able to start the game on Wednesday. Is that a valid statement?
Yes.
Great. We've got straight P to Q, and then P and Q are both true. Therefore, if he misses the game, he knows that the conclusion has to be true. Can I move it up, or do you guys need a second? Okay. I'm going to read B. If two angles form a linear pair, then they are supplementary. A and B are supplementary, so A and B must form a linear pair. Is that a true statement? That's tricky.
No.
No, because two angles could be like this, for example. A linear pair has to share a side. And it didn't say anything about that those supplementary angles shared sides. Because you could have these two angles like this that are totally separate, but they still add together to be 180, right? So supplementary angles cannot be a linear pair, but linear pair always has to be supplementary.
Mhm.
So this is false. This is not the law of detachment because it did not work. But if two angles are vertical angles, then they are congruent. If A, B, C, and D, B, E are vertical angles, they have to be congruent.
Sure.
That's a true statement. No matter which way you do it, if they're vertical angles, they're congruent. Yes?
How you
it
how would you write this on homework? Like,
would either be true or false, and you would just say, if it's false, you would give me an example of why not, like I did with linear and supplementary. Yes?
Is that PQQO?
Yes.
Okay.
Okay. So Michael knows that if he does not do his chores in the morning, he will not be able to allowed to play video games later that day. Michael does not play video games on Friday, so did he not do his chores Friday morning? Is that valid or invalid?
Invalid because maybe he chose not to play.
Maybe he knows. That's perfect. Exactly. That's why it's invalid. That's why you cannot say that that is completely true. Okay, now we're going to do a cool thing with the law of syllogism. The law of syllogism says this hypothesis with this conclusion. Then you make that conclusion a hypothesis and you have a new conclusion. Therefore, the hypothesis and conclusion can match. Now, it sounds really confusing, but it really makes a lot of sense when we do a couple of these. Okay, so am I going too fast still, or are we okay? You got to stop me because, you know, I'm chatty. All right. We've got these lists of conditional statements, and we're going to make the law of syllogism through them. If a bird is the fastest on land, then it is the largest of all birds. If it is the largest of all birds, then it is an ostrich. Okay, do you see how this conclusion matches this hypothesis?
yes.
Yes. Then we're going to say, if a bird is the fastest on land, then it is an ostrich. Does that make sense? So if you have the same conclusion for one and hypothesis from the other, basically what we did is we just canceled it out. And we made a new statement from it. Does that make sense? Want to try another one? I'm going to look at 3 and 5. If a bird is a bee hummingbird, then it is the smallest of all birds. If a bird is the smallest of all birds, then its nest has the size of a walnut hatchel. Do you see how I could take these two things and get rid of them? And I'm left with, if a bird is a bee hummingbird, which I cannot spell, then it has a nest of a walnut hatchel. Does this make sense? Yes, ma'am.
So you just took out those two and put the other two together.
Yep. If your conclusion and your hypothesis are the same, then you can remove them and you can have a new hypothesis and conclusion. Okay? So there's one more statement we can make from that, because we can use number 4. Do you see how we have if a bird is the largest of all birds, and we have if a bird is the largest of all birds up there? We can make if a bird is the fastest on land, then it is flightless.
All these statements have to be true.
Yes. Okay, before I stop, I want to talk real quick about biconditional statements, because that was on on last night's homework and I didn't really talk about it.